In section 5.3, we're going to talk about types of chemical reactions. So the majority of reactions are going to fall into one of 6 categories. Combination, where you combine things together. Decomposition, where you're going to break them apart. Single replacement, where you're going to replace one of the elements with something else. Double replacement is kind of where you swap. Oxidation and reduction, which we're going to talk about in the next section. And then acid-base reactions, which aren't really covered until chapter 9. So almost all chemical reactions are going to fall into one of those 6 categories. So let's look at them in a little more detail. A combination reaction is just like the name says. You're going to combine things together. So you join 2 or more reactants to form a single product. And you'll see this a lot of times called A plus B gives you AB. All right, so you have 2 reactants, you add them together, and you form one product that's the combination of the 2. And so examples of this could be the formation of ammonia. Get it down here so I can see it. Ammonia. Calcium and bromine form calcium bromide. And dihydrogen carbon, which is CH2 plus Cl2, to combine to give you dichloroethane. So just different combinations, but you can always tell they're a combination because you got 2 things on the reactant side forming one thing on the product side. A decomposition reaction is sort of the opposite of a combination reaction. What you're going to do is you're going to be tearing the AB down, so if you've got something made of 2, and you're going to separate it into its parts. So you're going to basically separate A from B and give you A and B separately as your products. So in a decomposition, you start with one type of thing, I should say, and end up with 2 types. So the ammonia, which has nitrogens and hydrogens in it as NH3, will give you N2 and 3 H2s. So again, you've got the larger, and then you separate it into 2 different things. And again, you can see organic synthesis as well, decomposition as well. A single replacement reaction is where you have a combination, usually, like one is combined together and you have a single element, and you are going to react those 2 things together, and then you're going to, where you used to have A by itself, you're now going to have B by itself, and A and C are then going to combine. And so you have the same number of reactants as you do products, but the product will be different. It'll be like a different combination of those same elements. So where you had A and BC, when you get to the products, you'll have B and AC. A double replacement, this is a swap. It's kind of like a square dance to me. If you kind of exchange parts or atoms and form 2 new compounds. So you got AB and CD, and they're going to swap. And so C is going to go with B, and D is going to go with A, and so that makes you have AD and CB. So all they did was swap. Remember that you've got a cation, a positively charged, and a negatively charged in each one of these compounds. So there's only one way they can do this, because you can't put 2 negatives together. You're going to have the positive one and the negative one go together. So again, just in summary, you have a single replacement. So you have sodium chloride plus bromine recombines to give you sodium bromide plus chlorine. Bromine replaces the chlorine in the compound NaCl. Double replacement, you have silver nitrate plus sodium chloride. They just swap. The silver, the first one in this, goes with the second one in that, so it's silver chloride. And then the first one, the positive one in this one, goes with the negative one in the other and forms sodium nitrate. So you're exchanging your ions together to form this new product. And so that's how those work.